Good morning. Thank you very much. First of all, I'd like to say that following up about knockout roses, it's really the reverse. If you grow a knockout rose in your garden, I'd like to thank you. Rick Prum's speech kind of dovetails very well into my presentation, completely by accident. But I'd first like to start by saying it's a pleasure to be here. It's a pleasure to be the closer in a multi-day series of presentations. But first and foremost, it's a pleasure to be here giving a presentation on roses in honor of Keith Thompson. Keith and I had a chance to chat before the beginning of today's events, and Keith was lamenting very quickly what most people lament about roses, which is, you know, darn it, my rose bushes, I get 6 or 7 years out of them, and then they just peter out. There's a solution for that, very straightforward solution, very easy solution. Unfortunately, that's not what this presentation is about, but maybe at the end, if there's time. I'm not a scientist. That'll become, if it's not already clear, that'll become very clear as we go into this. I'm a professional nurseryman, but you can't help but have a little science rub off in the process. We are an ornamental plant breeding company, and with a specialty in roses. So let's start by talking about this rose, Rosa chinensis. Rosa chinensis came into existence about 70 million years ago in southwest China. It has 5 petals, no fragrance, a flower that's so unimpressive that if you saw it in a rose garden, you would walk by it, or probably what you would do is look at it and say, what the heck is this doing in a rose garden? It's wholly unimpressive. This is Rosa sweet Mademoiselle. It came into existence this year. 70 million years and some many generations of rose hybridizing in between. Sweet Mademoiselle has 45 petals and has an abundance of fragrance, blooms prolifically, and is, I think you'd say, just by looking at it, kind of the epitome of what we think about when we think about a modern rose. So we're going to spend the next 20 minutes talking about how we got from Rosa chinensis to Sweet Mademoiselle, a few diversions along the way. First, Rosa chinensis is a very interesting plant because unlike almost all woody plants, Rosa chinensis does what we call repeat blooming. That means it sends up a shoot, it flowers, and most woody plants would call it quits at that. They're done for the season. Unlike most woody plants, and when I say woody plants, I mean plants literally that create wood, shrubs, trees, you know, as opposed to what we call herbaceous plants. Herbaceous plants are what got schnitzeled last night in your garden with the freeze that we just had. If you go to your garden and it's brown and crispy, the plants that are brown and crispy are herbaceous plants. They have fleshy plant parts that die down every year. In the case of annuals, they just die completely every year. So woody plants, is very rare to have a woody plant that will successively grow, bloom, re-grow, rebloom, regrow, rebloom throughout the season. That's very important, and the reason any of us grow roses, if we do grow roses, is because of the blood from Rosa chinensis allows the modern rose to repeat bloom. If Sweet Mademoiselle had that one flush of gorgeous bloom that we just saw in the spring, nobody would buy it. Rosa chinensis has taught us to demand much more from our roses. The genus Rosa, which all rose species belong to, is a member of Rosaceae, the family called the rose family. Rose family has many members you know very well because it's one of the 5 or 6 most important families from a food standpoint for humans, well, for animals too. You've probably already consumed a member of the rose family today. In fact, I checked. You did. There was a strawberry in the mixed fruit out there, so strawberries are a member of the rose family. Remember this flower as we go through some other well-known members of the rose family. Apples, cherries, strawberries. That's where your strawberry came from. Almonds, nut trees are actually in the rose family. Raspberries. And I'll pause here for a second. I think you see a theme developing as we go through these images of these flowers. living things are essentially characterized by how they reproduce. Plants reproduce through flowers. Okay, we're not going to quibble about the ones that don't, but essentially the plants that we're going to be talking about, the plants that end up in gardens, reproduce through flowers. And these, obviously a raspberry will not hybridize with a rose and produce offspring. But you can see the close structure: peaches, apricots, and pears. And there are more, but you get the point. Roses comprise of the rose family. The family Rosaceae is of about 130 or so genera. All these are genera: cherries, apricots, plums, peaches, etc. All these are genera in the family Rosaceae. The rose genus itself has between 100 and 150 species. Most experts put that the true number at the lower end of the range, but this is what botanists do. They quarrel and quibble forever about species. All the oldest species, such as Rosa chinensis, come from Asia, and they're just all about 60 to 70 million years old. The other species of roses are native to North America, and they are much younger, about half the age. They're about 30 to 35 million years old. So, and the other thing about rose species is they are native uniquely to the northern hemisphere. There are no native rose species from the southern hemisphere. So these horticultural crops that are grown for their fruit have been bred and selected over the centuries by humans for fruit size, for flavor, for productivity, how many bushels of apples can you get off one tree, for aesthetics and so forth. Roses are primarily bred and selected for their aesthetic value. There is, however, some rose species that are grown for their nutritional value. You wouldn't want to tuck into a bowl of rose hips in the morning. Strawberries are much more flavorful, but it is a great source of vitamin C. In fact, on a dry weight basis, rose hips contain more vitamin C than many more commonly associated fruits like citrus. And roses are also selected for their foliage. This is a species called Rosa glauca for fairly obvious reasons. Very ornamental foliage. This is Rosa sericea. Rosa sericea is the only rose with 4 petals, as we saw as we went through the Rosaceae illustrations. Everything had 5 petals, including our favorite Rosa chinensis. This is a specific variety of Rosa sericea called Kantha, and it is grown for, ironically enough, for its thorns. It is especially dramatic as an ornamental plant in the winter when everything is kind of died down around it and it's backlit by a low winter sun. It's just stunning, and it's very architectural as a plant. And finally, roses are often selected and even bred for their fruit display, like a holly might be bred for fruit display. Rosa moisei is an excellent example, and there are others of roses that really are selected to give an autumnal display, and this, depending on what happens with the weather, is good for 6, 8 weeks and maybe more, entirely depending on the weather, but very, very handsome non-floral display, but nonetheless a very handsome ornamental, aesthetic, horticultural display. Plants, in one very, very important aspect, have it all over us animals. They make their own food. This is pretty nifty. No hunting, no gathering, no preparing, no cleaning up afterwards. They were just completely fine sitting in one spot for, in some cases, up to centuries, happily going along with just a little bit of sunlight, a little bit of water, and sunlight, water, and a little carbon dioxide. And, okay, there are a few other things, but basically, you give it a little sun, a little water, a little carbon dioxide, your oak tree is good for 250 years. It has, and this is where this kind of plays very well into Rick's presentation, plants have very obvious disadvantage. Choosing a mate, impossible, just doesn't work. They have their mates chosen for them. And their mates are chosen, and chosen's not really the right word for a wind-pollinated plant, but most plants are pollinated by the wind. They don't have showy flowers like roses, apricots, peaches, pears, magnolias, and so forth. Oak trees, all the grasses that we eat, corn, wheat, all those kinds of things pollinated by the wind. So what happens in terms of the next generation depends entirely on where the wind was blowing from, the day the pollen was ripe, the day the female plant was ripe, receptive. Or maybe it rained for 5 days in a row and there's just not pollen, and then there's trouble for the next generation. So plants have a very, very significant disadvantage. Two kinds of flowers. Roses are an example of what's called a perfect flower. This, you probably remember some version of this from high school biology. Perfect flowers have both male parts, the staminate parts, and the female parts, the pistillate parts. That means this flower doesn't need another flower to make offspring. It will pollinate itself under certain conditions, assuming the pollen is ripe at the same time the female organ is receptive. This has advantages because one of Rick's birds could take a seed from a flower, a plant with a perfect flower, fly 10 miles away, excrete the seed, and that one seed germinating can make a new population of, geographically distinct, diffuse, and that can become its own kind of outpost to create the next population 5 miles away. The other kinds of flowers are imperfect flowers. That means a plant has either only male parts or female parts. This requires insects or wind to bring the two together. The benefit of that is in a perfect flower plant that self-pollinates, those offspring only have one genome to work with. In imperfect flowers, it's a bringing together of two genomes, the male genome and the female genome, so there's more genetic material to work with, even in within a species that obviously the offspring are very closely related in. So we are in the business of, among other things, breeding all kinds of plants, but especially roses. The first thing we have to do when we breed a rose is to turn our perfect flower into an imperfect flower, because if we leave the stamens on the plant, it might self-pollinate. We want to control the paternity. We don't want anything, we don't want chance, accidents, 70 million years of evolution to control the paternity here. That's our job. That's why we're breeding these. Whoops, I'm going to stick on that a minute. So the stamens, as you saw from the high school textbook, are around the outside of the flower, and here they are being just plucked off, so that the only thing left is the female part. It cannot self-pollinate. Black nail polish probably doesn't hurt, but I'm not sure, that's not necessary. Here we have the choice in the right hand, in the technician's right hand, the red rose, is now the pollen parent. You can see here the mature pollen. It's turned color from the yellow pollen that was on that. So this pollen is now ripe, and we will now take the father, the parent, the male parent, and bring it together with the female parent in a very basic mechanical process. This is rose breeding. That's all you have to do. Well, there's some twists. Next thing we do is, again, we want to control the paternity. So the only way to do that is to wall off our newly, hopefully fertilized female flower to make sure that no insect thinks it has a better idea about who the father should be and bothers our controlled cross here. We tag it so that we always know who the female is because it's on the plant. It's, whatever it is. But we tag it with a code to say this looks like cross number 1 in this series of crosses, and that will, if that cross is made, say, outside or in the greenhouse, we do everything in the greenhouse, in mid-June, the fruit will be mature by the end of September, seeds will be ready to harvest, and in that seed pod will be, in that rose hip will be from 3 to 5 to maybe as many as 10 seeds, which we will sow. Here's where it gets tough. Roses there are 100 to 150 species of that, and there are 35 million modern roses. Way too many. Nonetheless, those 35 million roses were really only created by humans from bringing together about 10 of those species. So we've stupidly ignored 90 plus species. And now rose breeding, like any kind of plant breeding, becomes, and even probably animal breeding for that matter, becomes a game of chance. A big commercial rose breeding operation will produce in one campaign, one season, will produce maybe as many as 500,000 seed. This seed will be germinated, and from the germination, we will go through and do negative selection. We pull out the bad ones, and then we keep the good ones. And eventually, we say, okay, these few are good enough to continue with. And we go through a process that can last 8, 10, or more years, continually selecting for what we've bred for. And we bring those two parents together, not because we like red and yellow, and we hope to mix red and yellow and get orange. This isn't paint. This is genetics. And so you're bringing two parents together for any number of reasons. It could be you're looking for disease resistance, you're looking for fragrance, you're looking for color, you're looking for flower form, you're looking maybe for all those things. So you select the breeder, the rose breeder selects the targets based on the outcome that he or she is hoping for. That outcome is highly speculative because modern roses are so many generations removed from the species that it's kind of just this stew of genes mixed up, even though it's only based on 10 species. You really don't know what you're going to get. And out of 500,000 seed, after 10 years of selection, maybe you have 10 varieties worth introducing that you've selected. This is a success rate of 0.0002%. Stated a little bit more negatively, it's a failure rate of 99.998%. This is a business we run. You know, there's not many businesses that are based on the premise that you can fail 99.998% of the time and still next year have a business. It's odd. We think that keeps the more intelligent people from trying to do what we do. They've got a better idea. But for us, it's not only makes sense. It's a passion. It's why we get up every day. We are, you know, kind of the what's the I forget what the saying is, but you know the eternal triumph of something over something, hope over. Yeah, thank you. That's why we get out of bed every day, and that's what we do. We really don't mind failing 99.998% of the time because it's so very sweet to succeed 0.002% of the time. Now we've got our sweet Mademoiselle rose. We're going to pretend this is a branch of sweet Mademoiselle rose. It is not. But the only way for that one, there's only one sweet Mademoiselle. It was created by a cross. It was one of the seeds in the seed pod. It grew up into an individual. Every other seed in that seed pod was different because the genes were, it was different recombinant DNA. Everything that goes into making offspring, just like you were different from all your siblings, every offspring in that seed pod from every seed in that seed pod is different from its offspring. So the only way to make sure that we always have, oh my God, sweet Mademoiselle, is to clone it, so that every copy is exactly identical to the original copy. We do that through stem cuttings. Here's preparing a stem cutting. Here's a one-node rose cutting. We have to keep a leaflet on the top. One-node rose cutting, applying rooting hormone to facilitate the formation of roots. Then we stick it in the rooting medium. And then you can see, maybe you can see it's a little faint, a mist boom going back and forth over these rose cuttings that we've stuck, basically to keep it turgid, keep it hydrated over that period of time that it takes to initiate roots, which is typically 7 to 10 days. You can patent a rose, and that is a little known fact. And if I had more time, I would talk to you about it. But our ultimate goal is to see our roses out in the public. to see our knockout roses in your garden, to see our knockout roses at a Dunkin' Donuts. I'll go into a Dunkin' Donuts even if I don't need coffee that's got knockout roses planted in front of it. Peggy Rosa Rockefeller Garden is the quintessential rose garden at New York Botanic Garden. Very geometric. You can see here just a lovely version of a rose garden. Nothing but roses, 100% roses. This is a local garden, the Rose Garden at the Morris Arboretum, that is, for me, a different view of a rose garden, and I think perhaps in many regards a more helpful view for home gardeners. Here you have repetition of catmint and other grasses and other perennials. At the end, anchored by a Lutyens bench, which, this is a lovely garden vignette. This is why we breed roses. I wish that dang bench at the top, somebody needs to get rid of that. That ruins the whole thing. Anyway, this is a view across the Morris Arboretum Rose Garden. Again, it's a tapestry of color, of texture, of form. You can see foxtail lilies as architecture, upright architecture with it. Whoop, what happened? All right, we'll stick with this because I'm out of time. And look at this, it's just this rhythm, it's a symphony. I would think if Monet saw this, he would move out of Giverny and move to the Morris Arboretum Garden, dive in head first. This is just an exceptional version of a rose garden. Here it is on a high summer day. So this is really why we accept a failure rate of 99.998%, is to see something that really is so ennobling, that really makes the world a better place, a more cheerful place. And I just hope that the next time you walk through the Peggy Rockefeller Garden or the Morris Arboretum Garden or Rosebush in a Garden Center, you look down and you have some appreciation for how it got here, and you say, congratulations, I know the odds were long, but you made it. Thank you very much.
That was wonderful. Questions? Philip.
Philip Gingrich, Ann Arbor. Fascinating. Could you tell us a little bit about the history of humans breeding roses? How far back does this go? Where did it start? I was surprised maybe 15, 20 years ago. I went to Pakistan in the spring, and there were roses everywhere. And so it's clear it's not just here.
It's not just here. There are clearly records going back to 3000 BC or so in the Middle East, and then, with civilization, the interest in roses kind of traveled with people. It shows, kind of what we were talking about in Rick's presentation. Well, we weren't talking, Rick was talking about, that roses are like dogs. We get to say what they look like. We breed them for our pleasure. They have no say in the matter. Even unlike dogs, they have less say than dogs. I think it's a reflection of our innate desire for beauty, our innate desire for decoration, garden decoration, home decoration. So as civilization evolved and moved around, the rose moved with it. And then as trade routes opened up, Rosa chinensis wasn't part of those roses that were bred 3,000 years ago. Then as the trade routes opened up in the Middle Ages and beyond, the Asian roses came into European centers and were successively bred into the European gene pool of roses. So it's just been, it's kind of co-evolved with us, and with a lot of intentionality on our part.
Other questions? Is there always a correlation? I know there isn't, but what is the correlation between color and perfume in the rose? I mean, do you sometimes go more for the perfume than the color?
I think there's something about a rose that no matter what, the first thing a person does is put his or her nose in it, and that's because we have expectations. And it's amazing, as a rose guy, it's amazing to see how many people will put their nose in a completely unfragrant rose and come up with a smile on their face. The power of suggestion is very strong. But there is a correlation. Often lilac or purple roses are very fragrant. Some red roses are very fragrant, but you breed for characteristics of one of which is fragrance, and you lose other things as you focus on on a thing, and there is often a very close correlation between fragrance and black spot, a positive correlation. The more fragrance, the more black spot. So you get something, but you give something up. Those are Keith's roses that die 6 years after he plants them, unfortunately.
Thank you.
It's a great 6 years, but it's a short 6 years.
We have one last question here, and yeah.
Wait.
I think we need a microphone. Thank you.
With such a high failure rate, what happens to those that don't make it? Are those the flowers I buy at the checkout counter in the grocery store?
I hope not. Those are supposed to be in the dumpster. So, who knows who fishes in our dumpsters? But no, they are actually roses that have gone off patent. The patent's good for 20 years. So you would buy a rose that was probably like Peace or Mr. Lincoln or Tropicana, some of the kind of the name brand roses. They don't have a royalty, so they're cheaper and they're cheaper to grow, and they're a commodity. So that's what you buy. It's probably distressed merchandise when you buy it, and $25 ain't that bad for something that's going to be with you for 25 years. So I'd upgrade.
Thank you so much.
Thank you.
Very
Thank you
much.
all.